Binomial products then. Binomial. Bi, of course, meaning two. Nomial, loosely meaning terms. So we're talking about playing with things that have two terms. In fact, I don't know if you know this or not, but a single term in a binomial is, of course, a binomium. That's the singular. But anyway, something like that. There's all sorts of different ways of doing it. You probably know the FOIL method. They say first outside, inside last. The face method. We know the face method? Let me show you the face method. It's basically the FOIL method, but you draw the lines in, because look what happens. I go, oh, first, x times x is x squared. Outside, x times 1, that's x. Inside, 6 times x, that's 6x. Outside, 6 times 1 is 6. But you know if you've done it correctly, because you end up with a face. You see, look, there's the chin, a nice smile. The inside parentheses, the nose, the outside parentheses, the ears, and there's a bit of the bump for the eyebrows. So you know if you've done it right. See, you get a face. Add your like terms and there's our answer. Okay. But what we do in maths is we can sometimes spend an inordinate amount of time coming up with quick ways of doing things. Right? So we'll spend a lot of time sometimes finding a quick way, because once we've got that quick way, we can do it again and again and again and every subsequent time. And that's where we come with our special binomial products. We see a plus b squared. Of course, we don't waste time doing that whole expansion. We know the pattern. A squared plus 2ab plus b squared. If it was a minus b squared, I get a squared minus 2ab plus b squared. In general, if I have to square out any piece of algebra there, it doesn't matter how many terms, I will always get this pattern where every single term is squared, and then I'll get 2 times every possible combination of 2 of the terms. So I'll get 2 times an AB, or 2 times an AC, or 2 times a BC, and so on and so on and so on. Oh, and of course, let's not forget difference of 2 squares. So we love our difference of 2 squares. X plus 2 squared then. So really, not that I'm suggesting you would write this down, but this is what we're saying. It's going to be, well, hang on, a plus b squared. So I've got a squared plus twice the product plus b squared. And I think most of us would just write that down, x squared plus 4x plus 4. But that's where, of course, it comes from. Let's just do a minus 1 for the fun of it. There we go. 3x all squared, 9x squared, minus twice the product, plus 4 squared. Difference of 2 squares, so 4p squared minus 25. Oh, hang on. Now I've got a binomial times a trinomial. Once it starts getting bigger, I sometimes think maybe it is easier to draw the lines so I can keep track of what's happening. So I know I've got 2 terms times 3 terms. So when I expand out, before I simplify things, if it can be simplified, I should end up with 6 terms. So I know if I don't have 6 terms, I've made a mistake. I've forgotten something. A times a squared and so on. Right, there's a times everything. Now we'll have 2 times everything. There they are. Collect the like terms. Got our answer. Brings me up this idea, what's known as the method of detached coefficients. It's just another way of expanding out these bigger ones, a way of doing it in a nice logical way. Saw it in a textbook that was written in, it was the 1800s. I think I saw it. I went, well, that's not bad. I wonder why they don't teach that anymore. So this is how you do it. You don't worry about the algebra, you just look at the coefficients and you say, well, I'm going to list all the coefficients of the first factor starting with the highest power. So alright, 2, -4, 0, -5. List all the coefficients of the second factor starting with the highest power. So 3, 4, -2, you see. Whilst it's not there, I still take into account every power. So that's why I've got the 0 there. Multiply all of the first row by the first number in the second row, writing the first result under the first number. It's a mouthful, but it's easier if I just do it. So basically I'm saying, hey, get that top row, multiply everything by 3, write it down. Now, because I'm multiplying everything by the second number, then when I write it down, I start under the second number. And then when I multiply everything by the third number, I write it down under the third number. Then I just add down those columns that I've created, and there's all the coefficients of my answer. And so my answer is, remember, the highest power will always equal the highest power times the highest power. So I know I'm going to start with x cubed times x squared, so I start with x to the power of 5. And I'll just write it down, fill it out, using all those coefficients that I just worked out. So that one was one of the examples I did before. So I would go, righto, I tend to put the longer one first. I find that easier. So I've gone 1, -3, 7, then 1, 2, multiply everything by 1, multiply everything by 2, add them together, there's my answer. It's kind of neat, especially when you've got really long ones times really long ones. It can be quicker than trying to go, oh, I've got to multiply this with this and this with this and so on. Like this. Whoa, look at that baby. Whoa, got to multiply that out. Well, each time in this quartic, each one of them, you'll notice, look at the algebra, it just looks scary. It still is 4 pronumerals multiplied together. Okay? They're all 4 pronumerals multiplied together. Sure, all 4 of them were x in this one. So, and just the powers are going down and the powers are going up. And it's missing the x squared y squared though. So I know I'm going to put a 0 for that one. And in the second one, it's a quadratic. Because look, each of the pronumerals have got 2 things. One's an x times x and one's a y times y. All right, let's put my coefficients down. Coefficients of the other one. Oh, I've got a missing coefficient there. There's no xy term. Multiply everything by 2. Multiply everything by, well, I didn't bother multiplying everything by 0. But multiply everything by -1, writing it under the -1. Add down. There are my coefficients. And there is my answer, because it should start with the leading term times the leading term is x to the power of 6. I know each piece of algebra will contain 6 things. I'm just going down by 1. So now I'll have 5 x's and 1 y, 4 x's and 2 y's, 3 x's and 3 y's, and so on and so on and so on, until I get to the end of my answer. Right? So our answer ends up being a sextic, and each term is the product of 6 pronumerals. Okay.